All right, so I hope to go over some things about the Hydrologic Analysis Lab. So first is talking about file management. You're going to be making a lot of different kinds of rasters. You'll start with your DEM, fill it, then make a flow direction raster, flow accumulation raster, hopefully a hillshade. So it's really important to have a consistent and organized naming convention. I recommend coming up with some kind of shortened name for your watershed to replace, kind of that DEM in these. So, for example, I did Jack Creek, which is pretty easy. Just do Jack underscore fill, Jack FD, Jack FA, and then, of course, flow direction would be the Jack FD, flow accumulations, the Jack FA. And this is important because raster names must be less than 13 characters. They cannot have spaces and they cannot start with a number. So coming up with an organized, consistent naming scheme that you'll be able to revisit and just will keep you organized. And it's just a good skill to build is that file management, because files sure do accumulate the further you get into GIS. The second thing I really wanted to introduce is the Strahler Stream Order. I know some of you might not be watershed scientists, so you might not be familiar with this stream classification. There's quite a few ways to classify streams, but Strahler, kind of refers to stream hierarchy. There's, multiple ways that people have calculated stream hierarchy values. But Strahler is by far the most common. So the way it works is, two first order streams come together, and that makes a second order stream. When two second order streams come together, it makes a third order stream, and so on. You'll see here that a first order stream and a third order stream coming together do not make a fourth order stream. It needs to be the confluence of two third order streams. I'll also take a minute here to kind of talk about symbology. So symbolizing stream order is, a big part of this lab. And this diagram starts with first order, and then the streams get thicker as we moved down to fourth order. This is a pretty common convention that the stream width gets wider. You might also see first order streams if you're somewhere where first order is generally intermittent. It's going to be a dashed line. One thing that I will be sad about is if you get crazy with the colors, like this diagram is, which is, of course, for educational purposes, so it makes sense. But, all of your streams' colors should be blues. Oftentimes, a first order stream might be a lighter blue than a fourth order stream, but they should all be blue for the most part. Just a couple examples of how stream symbology does matter. This is a map of the Bear River watershed that someone put a lot of work into. And if you're not familiar with it, when you first glance, it just looks like a jumble of streams. It's pretty hard to tell which way is up and which way is down, especially because the Bear River watershed makes this weird U-turn caused by lava flow thousands of years ago that actually started filling Great Salt Lake. So anyway, it used to flow towards the Snake. It was rerouted, and now it flows into the Great Salt Lake. So cool geology fact if that's of interest to you. But it's kind of hard to tell which way's up and which way's down. It's much more intuitive when you look at this map that symbolizes the Bear River as this kind of solid, or not solid, but darker line, darker, thicker line. The headwaters are over here in Utah, Wyoming, and then it flows up towards Idaho, does a U-turn, and comes back down towards Utah. So symbology matters. You will get to pick the Strahler Stream Order. Strahler Stream Order is really dependent on your flow accumulation threshold. So I just want to show you a couple things. So when you first make your flow accumulation layer, it's going to come up with the continuous color ramp. That's not what I wanted. Yep, okay. So when we have standard deviation, you can start to pick out the flow lines a little bit. And, if we're going from 0 to close to like 100 million, but, it's just a function of how this flow accumulation raster works, that close to the stream corridor, you might only have, 8 cells flowing in, so it's going to be really close to that 0 value. Whereas the number of cells that keep flowing in to the stream, quote unquote, stream areas grows exponentially. But you're going to classify, you're going to want to switch to classify to pick your flow accumulation value. I recommend setting your transparency on like 60 and laying it over a Forest Service map or a USGS map, some kind of map that'll show the NHD. And then you're going to want to make sure you have 2 classes, not 5, and then manual, interval. And then, you're just going to start playing around with what your flow accumulation value will be. I'll start with 10,000 because that's a good one. And yeah, if I zoom in, I can, that matches up pretty well with these kind of headwaters in the upper reaches of my drainage basin. Yeah, it does, but it doesn't extend all the way up. So one thing I might want to look at is going to like 5,000. And you'll notice when I go to 5,000, I pick up a lot more of these weird little dangler gullies. And just as you're going through and classifying your streams, I would much rather see you miss some of these headwater intermittent streams. So go closer to like 10,000 than 5,000 and not pick up, some of the weird little stragglers. I still have a couple, but I don't know how much higher I can get without missing headwater streams. 15,000 isn't bad. Anyway, so play around with it, but that's one thing I'm going to be grading on is how well your stream, your flow accumulation value sets you up to being mirroring, the USGS or the NHD data sets. And again, with that Strahler stream order, it's important to me that you guys understand what Strahler order is so that, so let's see. I'm going to open up. Yeah, so this is pulling from the NHD. And, I think this stream right here, that's a Strahler 3. So I don't want to see you pull something that's this tiny little drainage and mark that, classify that so that every single one of these little gullies comes up and you make this tiny little stream a third order. That will not reflect well. Yeah, the last thing that I wanted to show you is StreamStats. It's this really neat software that allows you to delineate a watershed much faster than the way we're doing it in ArcMap, although this will just give you a watershed boundary. It won't give you the streams. So I've zoomed into the area where my example basin is. One thing you'll notice, so it gets really marshy flowing into Ennis Lake, and it would make it really hard to delineate any of these basins. So try not to delineate a wetland and you should be fine. So I'm going to zoom in to Jack Creek. And again, I want to be careful where I pick my delineation, because if I pick it around here, I might just pick up this little tributary versus picking up Jack Creek. So I'm going to go just upstream of that and delineate, and this should take a second. Okay, perfect. And here's my basin. So I can actually just go ahead and download it in a variety of geospatial files. A shapefile, of course, will export into GIS. A KML will go into Google Earth. If I click continue, it's going to give me the option of calculating lots of different flow statistics for this drainage. So, there's peak flow, low flow, different monthly flows, seasonal flows. It's a really cool software. It pulls from a bunch of hydrologic models to get these. So, just in case you were ever wondering what the average flow in August of any given stream is, you can figure out using StreamStats. It might be helpful to pull the watershed that you delineated from this and compare it to what you produced in this lab. For example, let's see, I've done that here, and it actually pairs pretty well. You can see I picked two very different pour points, again, because this is a really marshy area. Yeah, there you go. Good luck on this lab, and let me know if you have any questions.